Example 6 is again related to loops, but now we will actually have a chance to see the case of nested loops. So when we actually have a loop built in as the task inside another loop. And the task is to basically check if a given matrix is symmetric. Now a matrix is symmetric when for a given matrix, whatever elements it has, you could think of it that when you slice it this way and fold it, then the elements on the opposite sides of this fold are the same. So for instance, if the matrix had here 0, 1, and maybe 5, then symmetric one would be only if it also had 5 here, 1 here, and 0 in here. So once we fold it, they kind of become respective. And those elements have locations, like what is on the diagonal, it doesn't matter, because those have the row index and column index is the same. So here we would have, for instance, element 3, 3 is of course the same as element 3, 3. But those on the opposite sides, with respect to the diagonal, they have, so for instance, if this is element 2, 1, then this is 1, 2. So checking whether a matrix is symmetric is basically checking if all those pairwise elements, which are like a mirror reflection of each other on the different sides of diagonal, are they the same. So how to approach it in Matlab? Well, basically we need a loop which will visit those pairwise elements. Now let's start from one loop. Or let's start with some matrix. I will even use the case we have now here. So 1, 0, 1. Then we had 0 to 5. And 1, 5, 3. So we know as a test case that it is symmetric. And now, this is one of those cases where we will need an answer yes or no, or be it true or false. And so we would kind of need this variable, which in programming is called a flag. And normally when you test for something, you always assume that flag, or maybe not always, depends on the case. But you can assume it to be right away from the start true, and then if some condition is satisfied, then it turns to false, or the other way. Now, in case of checking matrix for symmetry, we know that a matrix is non-symmetric if we find at least one non-matching pair. So actually what I will do is I'll call this sim flag maybe, so symmetry flag, and first I'll call it true. So I could write true like that, and Matlab will understand that I mean logical true, or I can just give it value 1, which for me will mean that it is true. And then I will start checking my matrix elements, the pairs, and if I find at least one which is not matching, then I will change my flag to false. Okay, so we need let's start from one loop. So when we think of matrices, we always think rows and columns. So now I will say that my first loop will be visiting the rows. So I want it to go, let's call that index, for instance, I. And I want it to be changing from 1 until the number of rows in my matrix. The matrix I gave is having 3 rows. So I could type it like that. But as I like to repeat over and over again, we should always write our codes in the way that if this input matrix changes, then it means that our code should adapt to it. So in this case, I will say size A1. This is the way also how I can check automatically how many rows my matrix has, because it's the size, it's the dimension, it's the kind of the length of the first dimension. Okay, and before I start do any checking, now I have to make sure that Matlab will also visit all the columns, because every time I want to be checking that pairwise combination. So row or element in row I, column J versus element in row J and column I. So now I'll write another loop which is inside this one. I'll call my second index J, and I want it now to visit all the columns. So again, using the size command, I say for I going from 1 to size of A in the second dimension. And now I can just type in that formula which was given in the task, almost same looking. But we want Matlab to react, because this is like a checking condition. So it means we have to use an if. So actually we have two loops, we have nested loops, and inside there is some if. So now, since I set my flag to initially true, so initially I assume the matrix is symmetric. So it means that I want to react in case our symmetry condition is not true. So if the element in place ij is not equal to its counterpart on the other side of the diagonal, then I want Matlab to react and change the flag to 0, which is our false. And I will not use any else, because if they are equal, I want it to continue. So that's how this flag thing works. Now I will need to end the if, and then I have to end, of course, each of my loops. So the inner loop needs an end, and the outer loop needs an end. And how this inner outer works. So remember, Matlab works in the way the rows are written. So it enters the first loop, it defines I to be 1, and then it goes in. And inside is another loop, so it enters it as well and defines j to be 1. Then it does whatever tasks it's given, and then it comes back to the inner loop, and it will change j to 2. So I will remain at 1 for as long as Matlab ran out of j options in here. So it will keep going, in this case up to 3. So I will be still 1, j will be 3. And that's when there is no more j possibilities. So it will go back to the outer loop and change I to 2, and then start over j changes again. So if we were to think how the pairs will go, it will be 1, 2, sorry, 1, 1, 1, 2, 1, 3. If our matrix is 3 by 3, in this case, there is no more indices for the inner loop. So it goes out to the outer one, changes it to 2, and then visits our j again. Once again, j finishes, so then there's 3, 1, 3, 2, 3, 3. And now since all the I options have been now used as well, then Matlab leaves the outer loop. So these are all it will do 9 steps. So the number of steps would always be the outer times the inner if we have fixed. Alright, so let's see if this thing works. So then after this we could still have, now after both loops have done their job, we could have another if, which now checks what's the final result. So if our flag is 1, we will tell it to display the matrix is symmetric, and otherwise the matrix is not symmetric. Let's run it and see what comes out for our example. Oh yes, I forgot end for my else. So the error here, at least one end is missing. I know I have carefully closed both the loops, but yes, at the end I forgot end for my if. So let's run it again. And I have the answer, the matrix is symmetric. One thing about this task is that it wouldn't work if we had non-square matrix. So that means that if we wanted to code not to crash, we might need to add an extra condition before our loop that first checks whether the number of rows and columns is equal in our matrix, and only then, if that is true, we evaluate the actual symmetry check. Let me give you an example here. If I add one more row, now the code will crash because it is trying to compare elements where one of them doesn't exist. So if we reach now row 4, it is trying to compare elements, for instance, in row 4 in first column with element in the fourth column and first row, which doesn't exist in this matrix. So what we can do is add this extra if in here and compare if the number of rows and columns are the same. So once again we use the size command in here. If size of our A matrix in the first dimension is not the same as the second one, then it means that we wouldn't do that symmetry check at all, and we can just display, for instance, that the matrix cannot be symmetric because it's not square. And then else, so otherwise it should do the job which we have already coded. So else assign the flag and go on with the checking and displaying. So now we have to remember that since we added an extra if, we also need to add the end at the very end of our code. So with this change matrix I did right now, if we run it once again, we should now get that message that the matrix cannot be symmetric.